4.2, we've talked a lot about the derivative as the average rate of change and the instantaneous rate of change, and talking about how they relate with each other. Here are a couple corollaries which we get from working with this section so far. So one corollary is all functions with the derivative equal to 0 are constant functions. And this is something that I've pointed out a couple times, but I want to formally give it to you as a definition. So here I've listed 4 functions that are all constant. So I'm going to take the derivative of them and notice a pattern. So if you have y equals 2, then y prime is equal to 0. If f of x is equal to 2/3, then f prime of x is equal to 0. If g of x is equal to pi, well, remember pi is about 3.14, g prime of x is 0. And if h of x is ln of 2, remember that ln of 2 is just a number, so h prime of x is equal to 0. Another corollary we have is that functions with the same derivatives can differ by a constant. What I mean by that is the only thing that's different between f, g, and h here is this is plus 0, this is plus 1, and this is minus 5. So in theory, they should all have the same derivative. Well, f prime of x was going to be 4x. G prime of x is equal to 4x plus 0. And h prime of x is also equal to 4x plus 0. So look, they're all the same. So if the derivative is the same, that means the only thing that's different about the function that they came from is a constant. And this is going to lead us into our next example, example 7, which says determine the function f of x whose derivative is sine of x and whose graph passes through the point 0, 2. These are typically called initial value problems, because we're given something about the derivative and something about either the initial value or a point on the graph, and we need to use that to determine the actual function. So first of all, let's think about what the problem is asking us. It's asking us to find the function whose derivative is sine of x. So we're going to do a little backwards reasoning on this. So we're going to let g of x be the function whose derivative is sine of x. So this means that g of x has to be negative cosine of x. This is because the derivative of negative cosine of x is equal to sine of x. So what we're doing now is we're thinking about what we would take the derivative of in order to get what we want. This is going to be something called the antiderivative, which I will give you a definition for in a little bit. So then f of x, remember f of x is going to be the function such that the derivative is sine. So this is going to be negative cosine of x plus the letter c, where c is any constant. Because the derivative of a function plus or minus any constant is always the same. So this is what we know. We know that the point 0, 2 is on the graph of f. What this means is that f of 0 is equal to 2. So all I have to do is plug in 0 for x and set it equal to 2. So negative cosine of 0 plus c is equal to 2. Again, this whole thing becomes this whole thing. I'm taking this 0 and I'm plugging it in right here. So from here we get negative 1 plus c is equal to 2, so c is equal to 3. And from that we get our conclusion, which is f of x is equal to negative cosine of x plus c, so f of x is equal to negative cosine of x plus 3. And there we go, there's our answer. So this is something called an initial value problem, which, as a heads up, the AP test loves to put on. So right now what I want you to do is I want you to try this one. Try to find f of x if the derivative of g of x equals 2x. Alright, welcome back. So we have our function that you've got. Let me just work it out and make sure we got the same thing. It's very similar to the previous problem. What we're going to do is we're going to find g of x in general. So g of x has to be equal to x squared. This is a little reverse thinking. Think of it as reversing the power rule. Normally, you would take, if I had x squared and I want to take the derivative, you would take the exponent, move it to the front, and minus 1. But now, what we need to do is we need to start with this 2x and reverse it. So this is right now a 1. So what we're going to do is we're going to add 1 and then divide by this. So we add, instead of minusing 1, we add 1, and instead of multiplying by the power, we're going to divide by it. So you get 2x squared divided by 2, which is x squared. That's one way to think about it. Another way to think about it is just, what do you need to put there so when you take the derivative, you get 2x back? So it's x squared since d dx of x squared is equal to 2x. So this means that f of x is equal to x squared plus some constant. But I also know that f of 0 is equal to negative 2. So then 0 squared plus c is equal to negative 2. So c is negative 2. So I get my answer that f of x is equal to x squared minus 2. And that's it. That's how you find a general antiderivative. So here's the definition of an antiderivative. A function, capital F of x, is an antiderivative of a function f of x if capital F of x is equal to f of x for all x in the domain. So what you need right here is that the derivative of capital F of x is equal to f of x for all of x in the domain. So here's some examples. If capital F is 2x squared plus c, then lowercase f is 4x. If capital F of x is x cubed plus 3x, then f of x is 3x squared plus 3. If capital F of x is sine, then f of x is cosine of x. When we find antiderivatives, we use a capital letter. That's the only reason I used a capital letter.